Hello, hello, hello. Good afternoon, Internet. Welcome back to the same math time and my same math channel. The same one. We're here on day 50 of NL Mathman's Math Help Streams. Wow. Day 50. Boy. I've had this one for a while. Hey, this is our, sequicentennial, I guess, right? Semi-centennial? I don't know. I don't speak languages. I just barely speak English, right? Anyway, this is our gold jubilee was 50 years. Anyway, I'm just making stuff up now. Just from trying to vaguely remember ways to say 50 different than just saying 50, right? But, I'm a math teacher. I'm not an ordinal number teacher, right? That's the word, ordinal numbers. I mean, sort of. Anyway, today we got here in the background another scene looking out of the other harbor in St. John's, right? This is not the Narrows, although this is a Narrows. This is, of course, looking out Kitty Vitty again. I decided to put up another picture of the same spot we were on previously for yesterday's stream. It's quite a beautiful area of the city. We can also here now take a look and see. Look, there we go. That's a nice view too, right? So this is sort of the same area as yesterday, just a bit earlier into the hike. This is like the very first hill that you walk up over. Basically, like behind my head here is just kind of like just a dock and a parking lot, right? But if you follow that road that's behind my head there, sort of to this direction, right, you'll get over to well, there's a sort of a river there, right? But on the far side of the river from Kitty Vitty, there's a spot where you can park, and then you start in on the trail here, right? And this is one of the first, like I said, one of the first hills you get to. So you get a really nice lookout over the city. Of course, this picture was taken in early spring, hence why there's definitely more of a yellow, sort of beige tone to the city. Maybe if I went up and took it now, we'd get some nice greens, right? Because things are coming in vibrant and dark and green, right? Because our growing season might not be long in Newfoundland, but when we get it, things sprout up with some vehemence, with some speed and rapidity and force, right? My lawn, like, I mean, real talk, you don't mow the lawn for like what 9 months of the year in St. John's. And then those 3 months when you do mow the lawn, you're mowing it like every 2 weeks, like clockwork, or it gets like really crazy jungly out there, right? So we can tell from this picture that it was indeed early spring, hence why everything is sort of brown and tan. Anyone who's watching this stream from elsewhere in the country or in the world, this is just because the land was recently under snow here in this picture. St. John's is not actually as beige as this. It's actually quite a bit greener. But anyway, to switch back over to this is a bit of a more impressive view looking out, right? And we got the green of the evergreens there to the left, which is, that's more accurate to what the color palette is like. She soothes your vision as you sail around her shores with a mixture of greens, browns, and grays, right? The houses lie scattered among the rocks in the cove, trimmed with orange, green, yellow, and blue, and Twilling Gate, Fogo, and Little Heart's Ease, Fortune, Trout River, and Firmuse. I mumbled that one. Anyway. It's a rocky isle in the ocean, it's pounded by winds from the sea. You might think that she's rugged and cold. She's home sweet home to me. There we go. There, quote some Buddy What's His Name on day 50. Look at that. That was even the serious stuff, right? That was the good stuff. That was like the folk songs part. That's the Wayne Chalk stuff, right? The man's a brilliant folk singer. And his spoken word poetry, I don't know if you've heard that stuff. It's fantastic. It's powerful. But anyway, yeah, rather than rambling about Buddy What's His Name bits and stuff, normally I just quote like the stand-up bits, right? But now we've gotten off onto reciting the lyrics to the songs. Anyway, over here on the side, we see what I'm getting to today, right? We got some angle properties and measures, angle bisectors. I'm going to do two different ways to bisect angles. I'm going to use the compass method and the protractor method. I mean, the protractor method is just using a protractor. But anyway, you'll see what I mean. Disjoint and overlapping probabilities and statistical permutations. Those ones are both for Calais for the same course. Disjoint and overlapping probabilities are something that you need to know in order to do the course that you're currently on. But again, right, like I said before, you're going to get tired of me saying these same things over and over again. but where you started on the grade 12 material, you actually didn't cover those parts. So yeah, I'm going to just sort of plug the gaps a little bit by going over those things there today, right? And I believe I've sent you a worksheet on that already, and I'll work down through it here live. Yeah, I mean, if you're there, you can drop in chat if you have any questions. But I imagine, a lot of people watch it after the fact, especially people who, work nights and stuff, as as I believe you do. Anyway, now yes, so Renetta, I will start in on some stuff for you. So it'll be angle, properties, and measures. So we are going to, let me see here. We're going to start off. Yes, I will start off with the angle, properties, and measures. So that is going to be Math 1102B. We're going to go to worksheet number 3. So let's switch on over here now to my document display. Here we go. So we see over on the side there to the right, Math 1102B worksheet number 3. But this is for Math 1102B Unit 2. So I'm going to have a few different bits from a few different activities from this unit that I'm going to go over. Right? Let me make sure. Yep, mic and everything's coming through fine. Good stuff. Okay. So this is worksheet number 3. Let's go down and do all the questions on this worksheet, just for the sake of going through and doing these and showing out some of the angle properties that are involved here. Right? So question 1. So Haley is creating a photo mosaic. Oh, Harley, sorry. Harley is creating a photo mosaic. He needs to decide at which angles to cut the images, determine the unknown angles in his design. All right. So now we're just determining the unknown angles in that shape over on the corner there. So I'm going to give myself a little bit more room to work. Zoom on in. There we go. So that's our shape. Okay. Break out my compass and protractor here. I will need several parts of this kit later. For now, though, I'm just going to use a straight edge. Let's go ahead and draw up a shape like this. And now these other lines, this is just going to be mostly approximated from what it is on the diagram there, of course. But you'll recall, as I've said before, that the actual way sort of that the angles are drawn on the sheet, you kind of can't trust that, right? I know that if I broke out a protractor and measured these are not going to be the same measures as the shape over here, right? But it doesn't really matter, because what matters when we're doing activities like this are what we've written in, not what it looks like. Now, generally, we will make a good faith attempt at having them be somewhat similar to what they look like, but I mean, 5 or 10 degrees off is totally likely. Not even possible. I would say it's probable that it's going to be a little bit off in each case. Okay, let me just... Boy. Odd one today for... I think I figured out what that crashing problem was. I did have 2 crashes last week, and apparently it was to do with my Logitech camera drivers. But now, of course, I've had to go redo all the camera-centric stuff. So there might occasionally be a more minor hiccup. I mean, blue screen of death is a pretty major hiccup, though, right? So I'm okay with the hiccups being, more minor than a BSOD, right? Okay, so here now we have to find angles A, B, C, and D, and how are we going to go about getting those? Well, there are a lot of different ways that we can find these. I'm going to work through them in order. Now, A, we know that, say, if we look at the this arc that I have here in green, see this section here? We know that that is a straight line, isn't it? That full angle there in green. So if that's a straight line, it's got to be 180. Straight lines are 180 degrees. So A is going to be equal to 180 minus 70 and minus 49. Right? We know that because all these 3 added together have to make 180. So A is definitely 180 minus this and minus this. So that's going to be 110 minus 49, and then A is then going to be 61 degrees. Okay, so now we know that A is 61. We can also, well, now we can use the same rule to figure out all the other three, right? Because we know that, for example, B here is opposite 70. And remember that when we have angles like this, like all around the same point, we know that any ones that are opposite are going to be equal. Because as long as all these lines are straight, which they have to be in these situations, then anything that's opposite, sort of across the shape like so, is going to be the same measure. So we know that angle B is equal to 70 degrees. We know that angle C is going to be the same as angle A, which is 61 degrees. Then angle D is going to be 49 degrees. Right? Sorted. That's all we got to do for that one. So for question 2 then, Chris is making roof trusses. So he wants to know, what does he want to know? Let's see. He wants to know the measure of the angles. The measure of one angle is shown, or the measure of the other 4 angles. Okay, so let's zoom back in here. Let's take ourselves a look at what this diagram looks like, because this is the important part, right? This diagram over here like so. There we go. So this is now question 2. So I'm just going to draw the diagram of sort of the relevant parts that we are looking at. So this is going to be angle W. This is going to be Z right here. This is a Y. This is an X. And this one here is 128 degrees, like so. Okay. Now, again, this one I am going to quibble with a little bit. Right? I know that from the word problem, I gather we are supposed to assume that, see where the hand is over here, that this line and this line are parallel, right? Because I guess if it's roof trusses and these are supports, we're supposed to assume that they're both like perfectly vertical, or at least at a 90-degree angle with the floor. Maybe not perfectly vertical depending on the ground of the foundation, I suppose, but we'll assume the foundation is level as well, I guess, right? But we're not actually told here that this and this are parallel, so to be perfectly accurate, or to be very pedantic, which I like being, of course, we would need to have an arrow here and an arrow here telling us that these two are parallel. Without that, we actually can't find angle W in any way. So, in this case, I think we have to assume that these are parallel, and we could reasonably conclude that based on the word problem that we have, right? But for these guys over here, we can get those ones fairly easily. Now I'm going to leave W to do last, even though W is the first one there, right? First one in order, of course, alphabetical order. X is, of course, 128 because these are opposite angles, right? And then Y, well, if you look at Y, I'll use red for it. This arc here is, of course, 180 degrees, right? So we know that Y is going to be 180 subtract 128, right? So then Y is going to equal 52. Since now we know that Y is 52 degrees, well, Z, which is directly opposite the Y, is also going to be 52 degrees. Now, remember, if these lines are parallel, right, and this is one transversal, one individual transversal, a perfectly straight transversal, and these two lines are parallel, we know that all 4 angles around this point here are going to be the same as all 4 angles around this point over here. So based on that property, we know that W and 128 have to be the same, right? And it's because this is one transversal and these are 2 parallel lines, right? Now, again, in the picture, we weren't shown that those are parallel, but in order to solve the question, we had to assume that. And from the fact that he's working on roof trusses, I think it's a relatively safe assumption, right? Either they're parallel or they're not made very well, right? They're either parallel or he's going to run into some trouble later on down the road. So I think we're safe to assume it. Over here now, it says a sketch of an outport door is shown. Ah, see, I was talking about outports just in my banter in the pre-stream, right? Sort of. I mean, I wasn't really talking about outports. It was St. John's. Although it's Kitty Vitty, right? Kitty Vitty is kind of like a little outport town stuck on the side of St. John's. And then with, some of the legitimately nicest restaurants in the world in it. Right here now, this is what they call an outport door. This is the barn style door, really. I've got one of these on my shed, and I don't live in an outport. We're going to go ahead and we're going to determine whatever we can about the various different angles off of this door. Now, the image itself is a little bit busy, as we can see here, right? So if we tried to figure out, say, exactly every single angle that we could off of this shape, you'd be there for quite a while. But I'm just going to draw it preserving the main points, the ones that we're sort of expected to be able to figure out. Right? There's a lot of angles here that we could probably safely assume are 90. Either they're 90 or, I mean, this is a pretty rugged door if they're not. So I think we're relatively safe to assume that a lot of those angles are 90. But the important one is going to be that 32 down below, and then we're going to have to assume that some parts of this door are indeed parallel with others. Okay, so let me keep. I haven't really drawn this one super well, have I? Well, crap. We're maybe a touch off in my diagram, aren't we? Boy, oh boy, boy, oh boy, boy, oh boy. Not super accurate here. Well, let's say that there is a yeah. Let's go ahead and make it like this. I'm going to color this in. And then I'm going to, let's see, do the same one over here and color that in. Okay, sorry about that. Just had some messages that I have to go check. Okay, so this is roughly what the door is looking like in this picture, right? So what we are told, sort of the angles that we are given on here, we're told that this one is 32 degrees. And now we're not told sort of anything else about the shape. And it's really unfortunate because without that, I mean, if we want to be completely pedantic, there's nothing else that we can determine based on what we know here already, right? But we are meant to assume, I can tell you that we are meant to assume that this is parallel with this, which is parallel with this. We are meant to assume those because we have to. And then we are meant to assume that, say, this side and that this is just one straight line, right? Because technically, to be very, very technical, if this is, say, a 2x4, right, it's not necessarily the same angles on both sides unless the 2x4 is perfectly planed accurately on both sides, right? Which, I mean, it may or may not be. But in this case, I think we have to assume that it is. Right? So we are making a fair few assumptions in order to get as many angles as we can on this shape. But what the question asks you to do is to fill in just as many as you can. So I'm going to go ahead and just do basically all the different angles that are around these two cross beams here, or the diagonal ones, right? So I know that 180 minus 32 is going to equal 148. So I know that this angle over here is 148 degrees, like so. Actually, how's about everything that I'm writing in, everything that I am adding, I'm going to do in blue, right? Because the red can remain being what was there before, and the blue is going to then be what I'm putting in. And now we know that since this is one transversal crossing two parallel lines, we know that this and this have to equal 180. And we also know that this and this are going to be equal. So we know this one here is 32 degrees. If that one is 32, then this one over here is, of course, also going to be 148 degrees, right? And then, yes, we're meant to see that for these top ones here, that this point and this point, this is perfectly above there, and these ones line up perfectly over here as well, which is another point that we would kind of need to be told. But actually, no, that one we don't really need to be told per se, because that's the difference between my drawing and the graphic over here. Because you'll notice on the graphic over here that this is a vertical line up through there, right? This is a vertical line up through there like that, right? And you can see that the ends of these boards are totally lined up, and the other ends over here of these boards are totally lined up, which means we can tell that these angles are going to be the same around here. We know that this angle is going to be a 32, this angle is going to be 148, this angle is going to be 148, and this angle is going to be 32. Right? And that's all that we can tell about this shape. Technically, this question is worth, like each of those ones are worth half a mark to find those. But honestly, like if you get the 148 and the 32, that's the lion's share of the work that you had to do on this individual section here. Okay, so that's the bit on angle properties. I actually started with angle properties. Right? I know we mentioned, yes, angle properties and measures. Okay, so those are the angle properties ones. Now, angle bisectors, I do want to mention as well. So now for angle bisectors, I'm going to pop over to the, let's see, yes, it's in the same guide, so just bear with me a quick second. And I'm going to zoom down. I'm going to go over a few of the questions from the assignment on this unit as well, because Renetta, you already submitted that one, and I want to go over a few of them. So we see over here now in my document display, we've got to measure these angles. We've got to use our protractor. Now, of course, I'm not just going to draw them out, because me drawing them out rather than measuring them is, that's an entirely different activity, right? That's not what we're really doing here right now, right? So what I've got is, like I said before, right? I actually managed to get some printer ink, so I have actual printed copies of these activities here now. And I just hope that some of the students who need this are actually going to be able to pay attention or be able to see it. It's, Anyway, so what we're doing, let me just zoom in a bunch here, right? So you can see, zoom in with my very nice handy dandy boom cam. So I zoomed this in, and now we see that what I'm doing is I've got the corner of the angle here, right? And then there's a leg of the angle across here along the bottom. So I've got to line up this sort of crosshair bit with the corner of the angle like so. And then I've got to line up this part with this leg of the angle like so. Right? So I see now that it comes over here. This one is 95 degrees. So the measure is 95 degrees. And what type? What type of angle is that? Well, we know that's an obtuse. Right? I'm not going to walk down through necessarily all of these, how to measure these angles, but I do want to point out some of them, right? I do want to point out basically how we determine which part of the angle that we measure. And the important part is this arc that's marked here, right? Sometimes it's more intuitive than others, but we always, always, always are going to be measuring the angle that is marked with the arc and not the other part of the angle. Like say we look at D over here, right? The arc is only small. It's really, really small. Can you see that? Let me zoom in even more. See that one there? That is the arc on D. We can see it like there, right? So what we have to use to measure that one is going to be our protractor, like so, right? We're going to line it up. And then we see that is about, we look over here, it's about 15 degrees. So this is a 15-degree angle, which is, of course, an acute angle, like that. Okay? I'm not necessarily going to do all of these ones on all of the pages, like I said, but I do want to skip over and do a few from the next page, which I also have here, because these ones, well, I mean, it's exactly the same activity as the previous one, just it introduces a few new wrinkles, right, that I did want to mention. And it is important to notice for one like, say, part D on this one, that what we're measuring is the whole outside angle. We're measuring this whole outside one here. But now I can't actually measure an angle that big with the protractor that I have, right? Because the protractor I have is the same ones that we provide in class, which are likely to be the same ones that most of my students are using at home, which are these 180-degree protractors. Now we can't measure this angle with a 180. There's two ways you can do it, right? You can either measure the angle that would be between the horizontal here and this part and then add it to 180, which I see some students do sometimes. Or the easiest thing to do is we know that a circle is 360, right? And if there's a big reflex angle like this, which is one that wraps around past 180, well, a reflex angle always has to be opposite of another angle that's smaller than it, right? Because a reflex angle is greater than 180. So the other angle that goes together with that one to make the circle has to be less than 180, which means this guy here, this 180-degree protractor, can indeed measure that angle. So I'm going to go ahead and I'm going to measure the smaller of the two angles. Right? I'm going to line it up like so. Right? We see it's nice and lined up, nicely lined up there. And I'm going to measure over here, and that looks to be about, yeah, it's about 15 degrees. Now, do I write 15 in here? No, of course not. I'm going to do 360 minus 15, right? Because if this small angle is 15, the rest of it out there has to be everything else that goes along with 360 to make a full angle. So that's going to be 345 degrees, like so. The type is reflex, and the measure is 345 degrees. Right? So just to show another one similar to that, right? Say if we had a question like F down here, which I'll slide up over there. If we have a question like F, I could measure this one out here by taking it straight across to be 180, then measuring this bit, but that's more work than you need to do, like I was saying, right? They don't, why make more work for yourself? Let's just measure the smaller of the two that's already there. Right, so I line my crosshair sort of up with the corner like that, and then we see that this goes down to about 105. So this angle, the one that I'm going to draw in red, this is 105 degrees, right? Sort of like this one up here was 15. Now, to get the actual angle that I'm looking for, it's going to be 360 minus 105. So that's going to equal 255 degrees. So this is again a reflex, a measure of 255 degrees, like so. Okay. So it's an example of some of the angle measures. I did also want to go on to showing, let's see, as parts of 1 and 2, I wanted to do those. Number 3, yes. So question 3 on the next page over here. So this is going to be the bisecting, right? So we're going to use a protractor to construct each angle, and then we're going to bisect them. To bisect each angle, let's see. So I'm going to do one through a protractor method, and then one of these through a compass method, I think. It's going to be the way that I show both of the two methods here. So for question C, we have a 102-degree angle. So I'm going to go and I'm going to start a line at the bottom, like so. Now I'm going to measure 102 degrees. Let's do it from this end of the line over here. So I've got a nice and big angle that I have loads of space to work with. 102 degrees, well, 100 is here, 101, 102, right there, like so. So this is 102 degrees. So now if I want to draw a bisector, well, drawing a bisector with a protractor is just painfully easy, right? It's almost, it seems a little bit silly. All we have to do is take 102 divided by 2, which is 51. Then we're going to go and we're going to put our compass back in the exact spot that we used to measure our 102-degree angle, like so. And then we're just going to measure a 51-degree angle, which is right there. So there we go. Right? So now this angle is 51 degrees. This angle is 51 degrees. So this one that I've just drawn, that is our bisector. Right, so it's a bisector just with the protractor method. Now I do also want to show the compass method, like I mentioned. Right, the compass method is definitely the more relevant of the ones to discuss, because it's the one that requires a little bit more work. But you are expected to know how to do the compass method, so I am going to show how to do the compass method for this exact question as well, and we'll see that it'll come out to be very, very, very similar. Well, not even very similar. It'll be the same angle in the end. It's just the way that we're going to do it is a bit different. Now, this is going to be similar to the stuff that Esther has seen relatively recently, and that is going to be using a compass. Right, so a compass is this thing. So Renetta, I gather you have one of those. I did see you doing this method, which you seem to have a good handle on, which is great, right? But I'm going to explain a little bit now about why this method works. So what we're going to do first to start the compass method is we're just going to take our compass and we're going to set it to any length, any width at all. Like I could set it like this if I wanted. I'm not going to. That's way too far. It's further than I need. I'm just going to set it to a width that I pick, so that if I put my the corner of my compass there and draw an arc, it'll cross both the legs of my triangle, right? Now, why am I doing that? Well, what I'm doing here now is I'm getting 2 points on the legs of my triangle that are equidistant from each other. And how does a compass achieve that? Well, remember, a compass is something used to draw a circle, right? And a circle is all the points that are the same distance from a center point in 2 dimensions, right? If it's 3 dimensions, it's a sphere. But so a circle is all the points that are equidistant, or the same distance, from the center point. So once I draw my arc correctly, it doesn't really matter the length of the arc. What matters, or so it doesn't matter the radius of the arc, sorry. The length of the arc does matter. It doesn't matter the radius as long as it's the same radius for here and here, because now I know that this point and this point are the same distance from the corner of the angle. Now what I can do is, again, I can have my compass set to any width I want. I'm just going to leave it the same. I could change it if I wanted to. The width doesn't matter right now. What does matter is that the width stays the same for these next 2 arcs. So I'm going to take the metal point of my compass and I'm going to put it on the intersection of the arc and the leg of the angle right there. Then I'm going to draw a new arc. And the important part of this arc is making sure that it sort of goes out into the center of where the angle is going to be. And it's the same deal over here. Going to do the same thing. Take the metal point, put it on this intersection. Then I'm going to draw the arc like so. And there. Now we've got it. We've got, see this point here? I now know that this point is the exact middle of the angle. Well, how does that follow? Is it, how does that make sense? Well, we knew that this point and this point are the same distance from the center. And we know that all points on this arc and all points on this arc are the same distance from those 2 points. So, since these ones are all compared to this point the same distance away, right? These are the same distance from here, these are the same distance from here. We know that this intersection of the 2 of them is going to be the exact middle of what the original one was. So now I can go ahead and draw my new bisector, which goes through those 2 points, like so. And there it is. It's a bisector for the compass method. All right, so I'm going to do question D as well for this one, because question D has a little bit of a curveball, because as you see, question D is a reflex angle, and quite a large reflex angle at that, right? So then what am I going to do for question D? Well, like I mentioned before, right, it is very difficult with a protractor like this to draw a 337-degree angle. Now, you can do it sort of by doing a 180 first and then adding, but I'm not going to mess around with that, right? What I'm going to, because that's a bit more lines than we need, right? What I'm going to do is I'm just going to do 360 subtract 337 is going to give me 23 degrees. So what I'm going to do is I'm going to draw a 23-degree angle, then I'm going to mark the other side of it as the arc that I'm looking for, right? Oh yes, and to be completely accurate, I should have marked that one, like so. Excuse me. And I'm going to go ahead and start off drawing a line. Now, like I said, I'm going to draw a 23-degree angle with this line that I've just drawn, like so. So, there's 20, 21, 22, 23. 23 is going to be right there. Now I'm going to take this and connect it up. There we go. So that part inside is a 23-degree angle, but remember, that's not the one that I'm looking for. That's not the one that I'm trying to draw. The one that I'm looking for is going to be this one out here. Right? So that's my 337-degree angle. Now, where's my bisector going to be here? Now, there is another way to sort of cheat with this one as well, right? I could do, well, what's 337 divided by 2? Well, that's going to be 118.5, right? I could do that, and I could measure a 118.5-degree angle from here over, right? Or what I can do is I can take half of this, half of 23, measure the bisector over here, and then sort of, instead of drawing the bisector this way, sort of extend it back out there. I can do either of those, right? But I'm going to do 337 divided by 2 is going to equal, no, wait, I said that wrong, didn't I? Yes, because 300, yeah, I don't know what I was saying. 300 divided by 2 is, of course, 150. 30 divided by 2 is 15, so it's 165. 165 plus 3.5 is going to be 168.5. Right? Yeah, arithmetic, right? It's tough stuff. So what I can do is I can draw an angle of that length from here, and that's going to work out just fine. Because, of course, the bisector of a reflex angle always has to be, well, it can be at most a straight angle, right? Because if the angle is 360, you bisect that as at 180. But really, if a test question is asking you to bisect a 360-degree angle, it's not very hard, no, is it? Anyway, going to take this one. I'm going to go to 168.5, like I said. So 160 here. 168.5 is about there. So now I'm going to go back to my original vertex, draw this line out like so, and there it is. So this one is now the bisector. Bisector with a protractor method. All right? Now, I am also going to show how to do a bisector like this for a reflex angle with the compass method. Now, it's not really that much more involved, to be perfectly honest. Right? It does sort of work out the same way, and there are, again, two ways you can do it. Right? We can do it like we're bisecting this smaller angle, and then we can just extend the line back the other way and draw it opposite. Or we can just straightforwardly do it like we are like we're bisecting this angle like it is there, right? 168.5 degrees. That original one was 337 degrees. You should always label. You should always, always, always label your angle diagrams every single time. Right? So this one is going to be, well, I'm not going to do it down here for this method because this method, like I've said before, is you got a bit more markings on there, right? So I want it to be a bit cleaner. I'm going to go ahead and take my pencil, take my pencil, put again, we're going to put the metal bit. The metal bit there is going to be in the corner. The lead is going to just cross both the lines, like so. And there we go. So now I have 2 points that are equidistant. Now I could go ahead and take it and do a arc here like this, do an arc here like this, right? And then sort of use this point and extend it on through. But I'm going to show that it works just fine. It works just fine with a reflex angle as well. You just are going to have to open your compass up and use it to be a bit wider. So I'm going to take it and I'm going to go with a bit of a wide stance over here, as if I'm like a sort of in the rugby scrum or something like that. Right? Now I'm going to, these had to be fairly wide angles because remember they had to cross like over here, right? So I'm now going to draw a rather wide arc from the top point, like so. And I'm going to draw another fairly wide arc from the lower point, like so. And there we go. We now have a point of intersection over here. It's a little bit gradual, right? Maybe a touch harder to pick out what exact part of these lines is the point where it meets. But I'm going to say it's roughly, I'm going to say it's pretty much there. What do you think? Looks good to me. Go ahead and draw that one. There we go. So this is the bisector. Right? Because the compass method works just fine no matter what the measure of your angle is. It's just sometimes you might have to take it and extend it a bit, but it's always going to work out as long as you're following the steps, right? The steps are not super complicated. You just draw this first arc, so that we get 2 points that are equidistant from the center, and then we can set our angle for the next arc to anything that we want. It just needs to be the same for both. Okay, let me see here now. Flip on back over to my intro screen. I believe now we've covered what I wanted to on that topic. Yes, that was what I wanted to go over on that topic. So Renetta, I hope that was useful for you. Just sort of spending 45 minutes in the middle of my workday to kind of exercise my vocal cords and my wrist a bit. But hey, that's what we do. That's what teachers are here for. Right? Next up, I'm going to go disjoint and overlapping probabilities and then statistical permutations. So it's going to be mostly on disjoint and overlapping probabilities. So Calais, this is going to be the point at which I guess it's going to start being relevant for you. Yeah, how's about I just flip on over to the worksheet that I sent you here, like so. Right, so I sent you a worksheet. This is just one that I found online really quickly. I didn't make this. but I just went online and grabbed it from the first one that I saw, right? And this is just an optional sheet just for you for a bit of practice. This is not like a required piece of work or anything like that in the program, right? But I think it's a decent example of a few questions that we can go over. Uh, but the most important thing that I need you to realize basically for disjoint versus overlapping events is sort of this probability formula, right? And the probability of A or B, right, is equal to the probability of A plus the probability of B minus the probability of A and B. Now you did see a bit of this in your current course as well, right? So this I said in the email earlier that this is covered in a previous course, and it was, but it was also mentioned in your current course as well. But sometimes, especially in probability and statistics sort of units, there will often be a lot of overlap, a lot of back and forth in what the questions are asking, what math the questions are asking you to do. And that's just sort of because the ways that the courses are set up. It's honestly, decently accurate to what it will be like doing stats or math in future courses, because especially stats, you need to understand the reasoning behind why you're doing what you're doing. Although that's true for all math. But you will also then have to understand sort of the situation that a question is representing in order to know what kind of math you're going to be using. Right? But what this basically tells us, what this principle sort of tells us, and I did talk about this a bit before, is that say we have two circles, right? We have B here and we have A here, right? And then this section in here, this blue section that I'm coloring in, this is A and B, right? They're in blue. Now, if I was to count everything in A, right, what would I be counting? Well, I'd be counting everything inside the green circle, right? If I was to count everything in B, I'd be counting everything inside this red circle. And then if I add them together, you'll notice that this bit in here, because it's in both of the circles, this one's going to end up being counted twice, which is why to get the probability of A and B, or also, I mean, it's the same thing, right? For the number of A or B is equal to the number of A plus the number of B minus the number of A and B. It's not so much the N or the P in front that's the super important part. It's the fact that this is how we deal with overlapping events, right? Because A and B overlap, they're going to have this sort of difference in between them. Tell you what, I will start off actually instead of doing the sheet first. I am going to bounce over and answer the question on the activity that you asked about specifically. This one is on a worksheet, so this is not like not sort of the same gravity as one of the assignments. So I will go through and answer this one for you. So this is Math 3101A, Unit 2, Worksheet number 1. And this is going to be question 9, is the specific one that you asked for. Right? So in a standard deck of 52 cards, determine the number of possibilities of drawing a single card and getting a club or a red. Well, the number of possibilities, so here we're looking for the n, the number of possibilities. We're not looking for the probability, but of course the probability is just the n divided by the total, right? So the probability versus the number is a very, very similar sort of measurement, right? But we know that, well, what's the number of clubs? Well, on your test, actually, you will be given a diagram of all the cards in a deck of cards. So if you're not aware, if you don't know much about decks of cards like these, right, and you're not aware of how many suits there are or how many of each card there are, well, then, you will be told that sort of on a test, and on an assignment or something like that, you can just ask me or look it up online, and I can tell you, right? But the number of clubs, there's, of course, 4 suits in a deck of cards, but 13 of the cards, a quarter of the cards are clubs, right? Now the number of red the number of red cards as we see here, right? Cards are either red or black, right? So half of them are red, half of them are black. So the number of red is going to be half the number in total, right? And we're trying to find the number of club or red. But in order to tell that, we need to get the number of club and red. And how many is that? Well, how many cards in this deck are going to be a club and are both going to be red? Well,